Okay, so on lesson 7.3, we are going to finish talking about a series, which again is the sum of the terms of a sequence. On 7.2, we talked more of an infinite series, or a finite series is what I meant to say, which means that your terms end. Today we're going to talk more about the infinite series, which means that your terms never ends. Because there are infinitely many terms in the series. Here's how you can tell the difference between the two if you're given a problem. If you have an actual number at the top, that means it's a finite series. If you have an infinity symbol, then it's an infinite series. And just to clarify, a finite series must have a sum. An infinite series may have a sum. It depends. And here's how you're going to tell. If the sequence is arithmetic, automatically there is no sum. If it's geometric, then it may have a sum. It depends. And we're going to get to that on the next page here in a second. Okay, so down here, we're going to use the formula to evaluate these two series. But before we do that, I have to give that formula to you. Here is the formula. So S will be the sum. Let me write down the formula first, and then I will tell you what the variables stand for. So S is obviously the sum. A sub 1 is the first term. R is the rate, so like what you're multiplying by. And then N is the number of terms. Okay, so down here in A and B, we're going to use this formula to evaluate the series. Okay, so I'm going to take first of all the first term, which is negative 45, and then 1 minus the rate. So if I look here, I'm multiplying by negative 3. And if you're not sure what you're multiplying by, you can always divide these two numbers, because if you're multiplying going this way, you're dividing going this way. So if you take 135 divided by negative 45, that's negative 3. And whenever you get a negative number, you want to make sure you put that in parentheses. And then N, the number of terms, there are 5. And then down here, I'm going to do 1 minus the rate. After you have those substituted in, you're just going to figure this out now. You don't want to put all this in your calculator. You actually want to do this first in your calculator. And you're going to type in it exactly how you see it. So 1 minus negative 3 in parentheses to the 5th power. That's 244. So now I'm going to take negative 45 times 244. This I can make plus, so I'm dividing that by 4. Okay, so now we're going to multiply these two numbers and then divide it by 4. So our sum is negative 2,745. Okay, moving on to B. So we're going to take our first term, which is 1/3. Whenever you have a fraction or a negative, you want to put it in parentheses. And then 1 minus, let's find the rate. Looks like we're multiplying by 1/3. Got to put that in parentheses as well, because again, it's a fraction, and I have 4 terms. And then the denominator is 1 minus the rate. All right, so you're going to put this in your calculator first to figure out what that is. Okay, and then I don't really care about it being a fraction until the end, so I'm going to multiply that now by 1/3. Okay, now I'm going to make it into a fraction because that's going to be my entire numerator. So math, enter, enter. So 80 over 243. And then 1 minus 1/3, that's 2/3. So you can either divide these fractions or you can multiply by the reciprocal. I'm going to multiply by the reciprocal, so 3/2. And again, I want a fraction as an answer. So math, enter, enter. So my sum is going to approach 40 over 81. Okay, that's the first page. All we did was use this formula so far. I went ahead and crossed off C because that's like what we just did. I think we're okay on those. Okay, so on the previous page I mentioned that if it's an infinite geometric series, you might have a sum. This is how you decide when you're going to have a sum or not. You have to look at the rate. So if the absolute value of the rate is less than 1, then you are going to have a sum. But first I have to write down that that means it converges, which means it has a sum. If the rate turns out to be greater than or equal to 1, then it diverges, which means there is no sum. So again, if it is greater than or equal to 1, there is no sum. If it's less than 1, I am going to have a sum. Here's how you find the sum. You take the first term and divide it by 1 minus the rate. So there's another formula. I went ahead and crossed off A and B, which all you have to do on these two is you're going to tell me whether it converges or diverges. So you have to figure out what you're multiplying by. So in this one, I don't really know. It looks like I'm dividing by something, but I want to know what I'm multiplying by. So if I'm multiplying this way, I'm dividing going this way. So I'm going to take -8 divided by -20. That's going to give me 0.4. I'm multiplying by 0.4. If I take the absolute value of that, it's still 0.4. So since my absolute value of my rate is less than 1, it converges. This is my explanation right there, which means there's going to be a sum. Okay, this one, if I take 70 divided by 50, that's going to give me 1.4. If I take the absolute value of that, that's going to be greater than 1, which means that it diverges. So there's not going to be a sum. Okay. Let's move on to the next page. All right, I'm not going to do number 11. That's a review from 7-2. I want to stick with what we know. So in number 12, it has infinity at the top. So what we're going to do is we're going to expand this series. So yesterday we did this without a calculator at first. Well, I should have crossed that out. Do not use a calculator. Okay, so I'm going to start with 2. I'm going to put 2 in there. So if I take 3 times 2, which is 6, and add 1, that's 7. I'm going to do 3 next. 3 times 3 plus 1 is 10. I'm going to do 4 next. 3 times 4 plus 1 is 13. And I can keep going, but it's going to keep on going forever and ever and ever. Now I got to figure out what the sum's going to be. Well, since it's infinite, I have to decide first of all if this is arithmetic or geometric. Looks like I'm adding 3 every time. That's arithmetic. We wrote down, or you should have written down, on the first page, that if it's arithmetic, there's automatically no sum. You could also look at it this way. If your numbers are getting bigger, there's never gonna be a sum. So if it's arithmetic, there is no sum. I'm gonna write that down. Arithmetic, no sum. All right, so down here I crossed off 13 because again, that's like what we did yesterday. I also crossed off number 18, but I didn't cross off 17. What I'm gonna do is I'm gonna rewrite 17 on the front because 16 and 17 are very similar. The only difference is that 17 has parentheses around the formula. So I actually want to do that first. So if you have a formula and you have a plus or a minus 1 at the end, it does matter if there's parentheses or not. So since this one has parentheses, then all of this goes together. So what you would do is just type that into your calculator, and as a reminder, you hit math 0. That pops up, and you're just going to type in exactly what you see. And you can use X instead of N, whatever. You get 26. So that is your answer to this one. This one, however, looks the same, but it's not because it doesn't have parentheses. So if you have a plus or minus at the end and there's no parentheses, this goes together. You have to add or subtract whatever you get in the end after you figure that out. So we're going to put just this in our calculator. Whoops. Okay, so x equals 0, 4, and just 2 to the x. So that's 31. This part's 31. And then in the end, I'm going to subtract 1 from it. So I'm actually going to get 30. So that's the difference between these two. So you have to really pay attention to if you have parentheses or not. Okay, on 14 and 15, they are both infinity. So I have to figure out, first of all, if it's arithmetic or geometric. If you recall from 7.1, this formula we use for arithmetic, and this formula we use for geometric. Well, if you look at this formula, it looks very much like this one. So this one's geometric. If you look at this one, it looks similar to this one. It looks nothing like this one. It has an exponent, so it's going to be geometric as well. These are both geometric, so it might have a sum. It depends on what the rate is. So here's my rate on this one, and here's my rate on that one. On this one, the absolute value of the rate is less than 1. So we are going to have a sum. So to find the sum, I take the first term. Well, since it looks exactly like that, I know what the first term is. It's 2. And then 1 minus the rate. You got to figure out what that is first, and you're allowed to use a calculator. Don't know if you need one, but that's going to be 1/3. And then you can either divide by 1/3 or multiply by the reciprocal. That's going to turn out to be 6. And then number 15, this time the rate is greater than 1. So automatically I know there is no sum. Right, last page. So I already did 17, we're not doing 18. This is a review from yesterday, or 7.2. So I'm just going to do 20 and 21. So I want to find the sum. Well, if you look, they're both infinity. And I should mention that they're both geometric. So that just means I have to figure out what the rate is. So what I'm multiplying by. And if you're not sure what you're multiplying by, you can always take the second divided by the first. So if I take -9/2 and divide it by 3, looks like my rate is I'm multiplying by -3/2. That is my rate. If I take the absolute value of that, I get +3/2. So since the absolute value of my rate is greater than or equal to 1, I can automatically say there is no sum. So I'm done with that one. Okay, the last one here. Again, I know it's geometric. I just forgot to write that in the directions. If I'm not sure what I'm multiplying by, I can divide the second divided by the first, because if I'm multiplying this way, I'm dividing this way. So if I take 4 divided by 5, that means I'm multiplying by 0.8. If I take the absolute value of that, that's still 0.8. So since my rate is less than 1, I am going to have a sum. So to find the sum, I take the first term and divide it by 1 minus the rate. The first term is 5, and then 1 minus the rate, which we said was 0.8. Make sure you do the denominator first. So if I take 1 minus 0.8, it's going to give me 0.2. And then if I divide those, I end up getting 25. 25 is the answer to that one. So that concludes lesson 7.3.